Good afternoon, everybody. As Fergus said, my name is Barry O'Donovan. I am with the management and operations team at INEX, which is the internet exchange for the island of Ireland, and I've worked there for the last 12, 13 years. What my talk about today is about OAuth with PeeringDB, and it's sort of why that might be useful to you as network operators. So these kind of sign-up registration boxes have become ubiquitous on the internet now. Sign up with Facebook, sign in with Twitter, and so on and so forth. I imagine in this room most of us may be quite skeptical about these and the information that they capture, but in general, for the wider base of internet users, these things are used every single day, millions or billions of times. If you're a site owner, they're really useful. The sign-up process is usually just 2 clicks. You avoid an awful lot of churn in your process. You don't need to make your users validate their email address, etc. And for users, the benefits are the same. It's just click and off you go. Also, as a user, and again, in this room, I would rarely use these tools, but if you do use them, with Facebook or all of these tools, you can go and manage centrally what other services you have given authorization to in the past. You can do some housekeeping in those and clean them up. So OAuth 2, this is the official definition of OAuth 2. It's an open protocol, which is to say that it's defined by RFCs to allow secure authorization in a simple, the emphasis here, by the way, is theirs, so they say it's simple, and standard method from web, mobile, and desktop applications. So why is this relevant for network operators? I think this is relevant for a few reasons. One of the ways that I'm going to show you how we've used it is to allow our members log into their area of our portal using their PeeringDB credentials. So if you are a network that is a member of more than one exchange, this is a great way of centralizing that authorization into IX member portals. It also means for large organizations that have a lot of technical staff, it allows you to centralize your users into one database rather than having to manage, add and delete users from multiple different applications. In the same way, if you are a business-to-business network, say you're an IP transit provider or something, it's another way to allow your customer networks to log into your portal. Beyond that, many of us will use different software packages, a lot of them homegrown in our own networks for monitoring and statistics and CRM and stuff. As you'll see, it's actually quite easy to create an OAuth service, and it's quite easy to create an OAuth client. And it's a good way that we're looking at in INEX to try and centralize our user management across a number of different applications. Just before I take you through the sort of OAuth process, there's just a few roles we need to understand. The first one is the resource owner, and that's the end user. It's you and I. So for the PeeringDB example, the resource owner is the PeeringDB user account, that username and password. The client is the third-party application looking to get access to some user's account or some resource in a user's account. So in our case, again, it's going to be IXP Manager. Another example of this might be, say, Fujifilm photo printing service in a pharmacy. You may give them access to your photos on Facebook on a temporary basis through OAuth so that you can print off photos. The authorization server is, in this case, PeeringDB, and the resource server is also PeeringDB in this case. So the authorization server is where we go and where the user ends up to give authorization to IXP Manager to get access to that information, and it's also where the resource, the user information, is stored. I suppose a little bit of history on this is a couple of years ago, someone asked for the feature to be developed in PeeringDB to allow it to be used as an OAuth authorization service. And in the discussions of that, at INEX, we are the developers of IXP Manager, and we agreed that we would be the first client of that service. You can't just use it without first going to PeeringDB and registering your client, your application. So this is PeeringDB's form for registering a new application. In this case, it's some particular instance of IXP Manager. So it's not enabled in IXP Manager when you take that off GitHub. You're authorizing or looking to register a specific instance, for example, INEX's instance of IXP Manager. PeeringDB will give you a client ID and a client secret. The client type is either public or confidential. Actually, in the case of IXP Manager, this should be confidential. The difference between the two is whether or not the browser, for example, will see the information. In IXP Manager's case, it won't. All that communication happens directly between the IXP Manager instance and PeeringDB, as we'll see shortly. There's 4 authorization grant types defined in the OAuth spec. The only one that really matters to us is authorization code, and that's the one that you would typically do with Twitter and Facebook as well. The last piece of information we have to give PeeringDB is a redirect URL. This is where PeeringDB will send the user back to after they authorize IXP Manager's access. And we have to name that here specifically as a security measure. So if we look at an example of how this works, if you go to INEX's IXP Manager now, because we've enabled it, we did that before Christmas, you'll find your typical login box, username, password, and then you'll see or login with PeeringDB. So the question here is, what happens when we click on login with PeeringDB? Well, the first thing that happens is when the user clicks on login with PeeringDB, the browser does a standard HTTP GET request back to IXP Manager into that /auth login PeeringDB URL. It's just a normal GET request. And what IXP Manager does is it generates a new URL, which is this auth.peeringdb.com.oauth2/authorize. And it sends, it's trying to give PeeringDB some information. So it's giving the client ID, and that's that ID that PeeringDB gave us when we registered the application, which uniquely identifies INEX's IXP Manager. The redirect URL, which is telling PeeringDB where to send the user back to after they authorize the transaction. And that, again, has to be registered with PeeringDB in advance. We're telling PeeringDB what we're looking for, what information of the customers do we want. In this case, we want the profile, which is their name, their email address, and whatever networks they're affiliated with PeeringDB. The last piece of information there is state. That's just a random transaction ID that allows IXP Manager to, first of all, know that this communication is what part of which transaction this communication is part of, but it's also a security measure. So this is what that looks like. Our user goes to her browser and she clicks login with PeeringDB. That sends in step 2 that HTTP GET request to IXP Manager. IXP Manager issues a HTTP 302 redirect. So it basically bounces the user's browser off to PeeringDB. And then PeeringDB will present a website to the user asking them to authorize IXP Manager's access. And that is what that looks like. So the user has essentially just clicked login with PeeringDB, and the next thing they see in their browser is assuming they're already logged into PeeringDB. If they're not, they'll have to log in. And then they'll get this authorize INEX IXP Manager. And PeeringDB is telling the user that INEX is looking to access their user profile, their email address, and the list of networks they're affiliated with. If they click authorize on this, what happens is PeeringDB will create an Auth Code, and it will send that back with the redirect URL that we've already registered. So we're again bouncing the user back to IXP Manager with this extra piece of information, the Auth Code. Some things to know here: the use of TLS is mandatory, so the transaction is encrypted end to end. The redirect URL again has to match what we've registered with PeeringDB, and the client must check that state as well. That state also prevents CSRF, so cross-site request forgery attacks. So that's what that looks like. Where we stopped in the last diagram is step 4, the purple one, where PeeringDB was giving that authorized screen to the user. The user clicks authorize. PeeringDB creates this new URL with this auth code and bounces the user back to IXP Manager. So from the browser's point of view, they've clicked login with PeeringDB, they've clicked authorize, and right now the browser is just spinning. It's waiting to decide what to do next. We've been redirected back to IXP Manager, but it hasn't sent any response to the user yet. So what IXP Manager does is it gets this auth code, and this auth code has gone through the user's browser, so it's not secret. It's not secret to the user. But it is the unique code that says that this user has authorized PeeringDB to give some information to IXP Manager. What IXP Manager does with this auth code is it creates a new post request directly to PeeringDB. So we go off to PeeringDB with the auth code. We send in the redirect URL again, just as a security measure. We give the client ID. which the user has seen as well through the browser. And then we give something that no one knows except IXP Manager and PeeringDB, which is the client's secret. And with that, what we do is we request directly from PeeringDB an access token. And that access token is a token that we can use now or indefinitely, or depending on how long the user or PeeringDB are going to have set an expiration date on it, to access the user's information directly from IXP Manager to PeeringDB. So we do a HTTP GET request looking for the user's profile with that access token. And assuming that everything is correct, we get the user's details from PeeringDB. We do some stuff in IXP Manager about creating the user, which I'll talk about in a second. But assuming all that goes well, the user gets logged in to IXP Manager. So just to reemphasize from the user's perspective on this, all they've really done is they've clicked login with PeeringDB. They've clicked authorize on PeeringDB, which they only have to do once. Once you authorize PeeringDB once, you won't have to do it again. So the second time the user does this, they'll click login with PeeringDB. There'll be 2 redirects in the background, and they'll just be logged into IXP Manager. This is an example of what PeeringDB is giving us, those 3 scopes that we asked for, the user's profile, their email, and the networks they're affiliated with. So we're getting their name, we're getting their email address, we're finding out whether those emails have been, that email address is verified or not, and we get a list of networks. All we're really interested in terms of the networks for IXP Manager's point of view is the AS number. The permissions tell us whether on PeeringDB if the user can read only, can rewrite, or can admin the network. So now that we have this information from PeeringDB, what do we do with it before we actually log the user in? Well, there's a few things we have to do, a few steps we have to work through. The first thing we do is we make sure that JSON document is structurally okay and all the details that we're interested in are present. We make sure the user is verified with PeeringDB and that they've verified their email address. So if they haven't completed PeeringDB sign-up process, they're not going to be logged into IXP Manager at this point. Of the list of networks that the user is affiliated with in PeeringDB, we have to actually also check that at least one of those networks is a member of our exchange. Otherwise, there's nothing for them to see here. And then if you spotted there, PeeringDB give this ID, which is just put in here as quad 9. When we create users through this OAuth mechanism, we include the PeeringDB ID in their database object. So we see if the user has already done this before, in which case we load up that user. If they haven't, we're going to create a new user with the details that we've gotten from PeeringDB. We then need to work through this list of networks. So we want to make sure that some admin hasn't removed this user from some networks that they've been previously affiliated with. And if they have, we're going to remove access from IXP Manager as well at this point. We'll also add any new networks. That will only apply really to consultants or contractors who might work for multiple networks in the same exchange. But if they've been added to any networks, we're going to add access to those on IXP Manager also. At the end of this process, either the user has no networks, in which case we're just going to delete them and not log them in. Otherwise, we're going to log them into one of those networks. And once they're in, if they have multiple networks, they can change that within IXP Manager. So one of the obvious things here is we're effectively outsourcing user authorization to a third party. So we have to ask ourselves, do we trust the third party? And this will apply to your own application, your own trust model. But for us, we have to ask the question, do we trust PeeringDB? For us, and we look at the risk, we look at the exposure as well, but to give the answer in advance of that, yes, we do trust PeeringDB in this instance. And we trust PeeringDB because this is a relatively small industry in which we work, especially the interconnection industry with IXPs and networks, the various forums that we attend like UKNOF and RIPE and peering forums. And many of us know the people who are involved and volunteer with PeeringDB. Anyone who has a network that have created a PeeringDB account will also know that they're pretty strict about verifying that you actually have a right to access that network, create that network on PeeringDB. So we are happy that we trust PeeringDB in this instance. What are the risks? Well, the OAuth protocol itself is well understood. It's been around for nearly 10 years. There are RFCs, but most importantly, it's used millions or billions of times a day by these much bigger, the Googles, the Facebooks, etc. So in terms of the protocol itself, we're fairly happy that we trust that. In terms of coding IXP Manager and PeeringDB, neither of us went off and wrote this code from scratch. So PeeringDB is using a very well-established Python library for the OAuth server, and IXP Manager is using a very well-established PHP library for the OAuth client. So these libraries have been used, are used in each of them in thousands of applications. In terms of implementation issues, well, I've walked you through what we do when we get that information back from PeeringDB. As part of the process of programming it, we went back and reviewed our authentication code and the controllers that manage all of that, which was a good exercise. Obviously, with any software web-based application, I can't guarantee that there aren't any bugs in there, but we're fairly happy that it's working as intended. The second element here is what's the exposure. So what if we get this wrong? What if some nefarious person in PeeringDB creates fake accounts? What if our security mechanism is incorrect? What is the exposure if someone gets into a member account that shouldn't? In reality, this isn't a banking application. This is really just a dashboard showing you some of your details at an IXP. You're going to get port details, IP addresses, not details. All of that information is already widely available through IXF member exports, through PeeringDB databases, even the IP addresses through traceroutes and everything else. The one thing that you would get that you wouldn't ordinarily get is traffic graphs and peer-to-peer graphs. That would certainly be unfortunate, but I don't think that would be the end of the world. Users that are created in this mechanism are created as read-only by default. So they have no write access, they can't create any other users, they can just go in and look. The other thing that's important here is that super admins, so employees of INEX, cannot use this mechanism. You can't use this mechanism to log in as a super admin. So you can only use this mechanism to log in and create a read-only user. And someone else in your organization can elevate that user to read-write for that particular member at a later point. That's absolutely fine, but the default is read-only through this mechanism. So what's our experience with this and how has it worked so far? We launched this last August, at the end of last August. We did an unusual thing in that normally we wouldn't announce technical features to the full membership. We'd just announce those to our technical mailing list. But we actually announced this to the full membership mailing list, particularly to let all of those networks know that people in their organization could now log into the IXP Manager account if they have PeeringDB credentials. What we found in the first 2 months with 26 new users created, and remember, there's 100 members at INEX. Most people wouldn't log in week on week. Only those who are really interested in their peer-to-peer graphs are the people who would log in routinely. So getting 26 new members in 2 months is quite a lot. 19 of those was via PeeringDB. The percentages are wrong there. So that's about 73% of new users that were created that didn't require the INEX support team to take any action. I say feedback has been 100% positive. We've got good feedback from INEX members. We've got no negative feedback. We presented this at EuroIX as well before Christmas, which is the Association of Internet Exchange Points. The feedback there was all positive too. No member has requested an opt-out. So a member can come to INEX and say, look, that's all well and good, but I don't want people logging into my account using PeeringDB credentials. But no member has requested that opt-out. The only issue that we found is mailing lists, is mailing list subscriptions. You can subscribe to the mailing list through IXP Manager. And what we've found is that a handful of members have a pre-existing account where they're subscribed to the mailing list, and then they've created a new account where they're not subscribed. And in the automation to Mailman, we're subscribing, unsubscribing them in a bit of a loop. So we just need to fix that. In terms of IXP Manager itself, this was released in version 5.2 last September. I know at least 3 IXs that have enabled it already, besides INEX. Enabling PeeringDB OAuth is actually really easy in IXP Manager. You just have to go to PeeringDB, register your IX's version of the application, and then just add those secret IDs to the config file. And once you do that, it's on and it just works. There's tooling within IXP Manager to show you which users came from PeeringDB and which didn't. And there's various logs and stuff as well. If anyone is interested in OAuth itself as a service, all of the RFCs are linked here. There's an excellent blog post as well, OAuth 2 Simplified, which probably does a better job than I've done of explaining it. If you're interested in programming it, what we've done on IXP Manager is we have used a PHP library called Laravel Socialite, which in turn uses a League of Extraordinary PHP Packages, which is really where all the main code is. That's been around for years. And for PeeringDB, they've used the Python Django OAuth toolkit via OAuth lib. So again, neither of us have reinvented the wheel in this. We're using some libraries that are well established. To be perfectly honest, the coding of this was far easier than I thought it would be. We've really just created 2 new web endpoints. One is the one that redirects you to PeeringDB, and one is the one that handles the return from PeeringDB when you get the user information. Within standard web application frameworks, this stuff is actually much easier than it used to be. I'm nearly ashamed to say. So thank you. That's the end of my presentation. I didn't put my email address in that. If anyone wants to email me about any of this, you'll get it through my Twitter handle or barry.o'donovan@inex.ie. Thank you very much.
Thank you very much, Barry. And do we have any questions? And if you have a question, wait for the microphone and then your name and affiliation, please. Nothing?
Okay.
You must have been excellent talk with no questions.
I did a good job. Thank you very much, folks.
Okay, thank you.